In this lesson, we'll do another example problem on finding absolute extreme values on a closed interval. So here we have the function f of x equals root 4 minus x squared on the interval minus 2 to 1. So remember, to find the absolute extreme values, we need to first find all the critical numbers, then evaluate our function f at the critical points and the endpoints, and then just compare our values to find the absolute max and the absolute min. So the first thing we need to do is find our critical points, which means we need to find the points where our derivative is equal to 0 or undefined. So the first thing we're going to do here is use the chain rule to find the derivative of this function. So this is f of x equals square root 4 minus x squared. So on a scratch sheet of paper, go ahead and pause the video and find the derivative of this function. You should get as the derivative 1 over 2 square root 4 minus x squared, and then times the derivative of the inside, which in this case is negative 2x. So this is going to give us, our 2's will cancel, and we get negative x over the square root of 4 minus x squared. So for our critical points, we need to find the points where f prime is equal to 0. So our f prime is a fraction. A fraction is equal to 0 when its numerator is equal to 0. So that will be at x equals 0. And then we need to find where f prime does not exist. So f prime does not exist, that's when the denominator is equal to 0. So we get root 4 minus x squared is equal to 0. Squaring both sides gives us 4 minus x squared equals 0. That gives us x squared equals 4, which gives us x is plus or minus 2. Now our interval is minus 2 to 1, which means that the plus 2 we actually don't need to worry about because that is not in our interval. So it's only x is negative 2 that we need to worry about here from our f prime does not exist. So the critical points that we need to look at are x equals 0 and x equals negative 2, which also happens to be one of our endpoints, and then the right endpoint x is 1. So we'll set up our chart. So again, we need to find the values of our function at our critical points and at our endpoints. So our critical points, we had 0 and negative 2. And then our endpoints were negative 2, which was also our critical point, and 1. And again, we don't need to worry about that critical point at x equals plus 2 because that's not part of the interval that we're considering. So now let's plug back into our function f of x is root 4 minus x squared. When x is 0, 0 squared is 0, 4 minus 0 gives us 4, and the square root of that is 2. When x is negative 2 squared is 4, 4 minus 4 is 0. And when x is 1, we get root 4 minus 1, or the square root of 3. We know that 2 is bigger than the square root of 3, because root 3 squared is 3, whereas 2 squared is 4. So 2 is bigger than the square root of 3, which means our absolute max is when x is 0, so is at the point 0, 2, and 0 is our smallest value, which means that our absolute min is at the point negative 2, 0. So our absolute min occurs at the point x is negative 2, f of x or y is 0. And again, we can check that with a graph of this function on the interval negative 2 to 1. We see that on this closed interval, our absolute min is in fact at the point negative 2, 0, and our absolute max on this interval is at the point 0, 2. So again, the key for solving these problems, so for finding extreme values on a closed interval, so to find the absolute max and min values of a continuous function f on a closed interval, we first find all the critical points, which means we need the derivative 0 or the derivative undefined, evaluate our function at the critical points and at the endpoints, and then just compare all of the values. And of course, when we say values here, What we mean here are the function values, so the f of x values we plug into our original function, and we find the absolute largest and the absolute smallest, and that gives us our extreme values.